AP Stats. Here we are back working on, this is the second part of your notes, the quiz 10.1a, and hopefully you've taken a second to try the problems on the front and the back of this page. If you haven't, pause the video and give it a try, and then we'll check the answers together. But here you have two large bins of several thousand plastic beads, so it's a very large population of beads. Bin A is 60% red beads. Bin B is 48% red beads. So that's your true or proportion of A and your true proportion of B. Suppose you take a random sample of 80 beads from each bin and calculate P hat A, the proportion of red beads in the sample from bin A, and P hat B, the proportion of red beads in the sample from bin B. So we're not trying to find the population proportion, we already have that. We're trying to estimate to see how likely it is to get a sample of a certain proportion. So describe the sampling proportion of P hat A minus P hat B is our first question. So we want to, when we're describing a sampling distribution, we want to make sure we're describing shape, center, and spread. So our shape will be approximately normal as long as the amount of successes and failures for both bins, both colors, are greater than 10. And since, let's see, NA times PA would be 48, and N times NaQA would be 52, and NBPB would be 38.4, and NBQB would be 41.6. Since these are all greater than 10, then we know that this distribution is approximately normal. Now make sure you see where I got all of those numbers using a sample of 80 beads from each bin and the proportions that we were given. Secondly, we want to look at the center, and the center of a sampling distribution of two P hats is going to equal the difference in the true proportions. So the mean of P hat A minus P hat B, that's how you would want to write that, would equal the true P A minus PB, which would just be 60 minus the 48, which is 12%, or 0.12. And then spread, we can use the standard deviation formula, big square root of PA QA over N plus PB QB over N, and we're going to use these the true proportions as long as we have them, and we do. So that will give us 0.6 times 0.4 over 80, and 0.48 times 0.52 over 80, which will calculate to 0.078. So that's what our distribution will look like of the two sample proportions, their differences. And so the second question has, what is the probability that the proportion of red beads you select from bin B is higher than the proportion of red beads you select from bin A? Okay, well, we already have the distribution here, and we said it was going to be A minus B. So let's think about that. If we have the center at proportion of A minus proportion of B, and we know that to be 0.12, and we're trying to see the probability that the proportion of red beads you select from bin B is higher, so we're actually looking for negative values in this difference. So if we can find where 0 is, the difference, we want to find the proportion, the probability that it's less than 0. So the probability that our p hat A minus our p hat B is less than 0, we could use norm CDF of negative infinity to 0, and we could put in our mean, 0.12, and our standard deviation, which was up here, 0.078. Make sure you're using the standard deviation of the sampling distribution, and this should come out to be 0.0618. Be really careful to think about if you want a value above 0 or below 0, depending on what your question is asked. Flipping over